The topic for today is Newton's second law of motion. So we did the first law and second law, right? So first law was basically the first law actually defined the state of rest or the state of like motion, whatever it is, right? And it defined a body without considering any external forces. So we are not considering any external forces. That is why a body will remain in the state of rest. A body, this pen, this pen staying in my hand right now will continue to remain in my hand unless I move my hand or unless something external makes the pen to move, right? Unless and until I don't move it, it will not move. So this was the essence of the first law. So first law was basically concerned with the forces that do not act on the body. So we are not considering about any forces, we are just considering about the state of the body. And when there is no external force, that is when there is no external force acting on a body, no matter it is in maybe no matter it may be in the state of rest or in the state of motion. State of rest mouse, yeah, the motion mouse, it doesn't matter, right? A body will remain in that state until and unless some external force will tempt the body to move or to stop. So if a body is moving and if the body is stopping all of a sudden, which means there is some external force that is acting on the body and that is preventing the body to move forward and then stopping. Or a body in the state of rest will start to move only when some external force is applied. Other than that, it will not have enough energy within itself to move itself, right? Nothing like that is possible. Something has to supply energy to the body so that it loses its state of motion or the state of rest. So that was Newton's first law. Newton's third law was every action has an equal and opposite reaction. So whatever action you do, physical, mechanical action, what you do will have an equal reaction, but will be in the opposite direction. Like I give you the example of rocket. So a rocket will fire its engine downwards, right? So the engine is firing downwards. So since the engine is firing downwards, but we see that the rocket is always going upwards. So why is that? Why is the rocket always going upward? That is because of the Newton's third law of motion. So every action has an equal and opposite reaction. So the action of this rocket is the downward force of the engine fuel. So the fuel is burning, and that burning fuel, hot high pressure fuel, is burning, and that the product of burning is pushed downwards. So because of that downward force, an equal force is exerted by the rocket in the upward direction. So that's the reason why the rocket moves upwards. So that is the Newton's third law of motion. Now we come to the second law of motion. So second law of motion, to understand second law of motion, we need to understand what momentum is. So P is called the momentum of a body, and it is always the product of mass of the body and the velocity of a body, right? So if you want to change momentum, for us, like if I have a 5 kilo ball in my hand, right? I have a 5 kilo ball in my hand, and initially it is said that it has a momentum of 20 unit, whatever it is. It has a momentum of 20 unit, and I want to change the momentum to 40 unit. So the only way I can do this is by increasing the velocity, because the mass of the body will always remain constant. So I'm not changing the body. I'm keeping the same 5 kilo mass ball, right? But I just want to change the momentum. But to change the momentum, we know the formula of momentum as a product of mass into velocity. Now, for a fixed body, for a definite body, the mass will always remain the same. I'm not taking out any mass from the body, or nothing else is contributing to the mass of the body. So it is only the body that has a particular mass, that is 5 kilogram. So if I don't change the body that is of 5 kilogram and I change the velocity, only then the momentum will increase. Or if I decrease the velocity, the momentum will decrease. So change in momentum is only possible by change in velocity, because the mass will not change. Mass is always a constant. So Newton's second law of motion states that force is directly proportional to change in momentum, rate of change of momentum. Or in the bookish words, Newton's second law of motion states that the rate of change of momentum is equal to the force, or the rate of change of momentum is directly proportional to force. So now we can derive an equation for force from this relation. So according to Newton's second law of motion, force is nothing but force is directly proportional to rate of change of momentum. So one important thing I'll let you know today, whenever you see rate of change, whenever you see this line anywhere in physics, chemistry, bio, whatever it is, rate of change means something is changing. Yeah, something is changing with respect to time. Okay, so rate of change of velocity means your velocity is changing with respect to time. Rate of change of mass, if it says the mass is changing, rate of change of mass is something, then mass is changing with respect to time. Rate of change of acceleration, then acceleration is changing with respect to time. Rate of change of anything is known as, is defined as something is changing with respect to time. So we have something changing here with respect to time. So according to this definition, force is nothing but change of momentum. So we denote change of anything by delta of that quantity. So this triangle is known as delta, and now momentum is changing, so delta p divided by change in time or total time, whatever it is, just put delta t. So force is directly proportional to rate of change of momentum. So this is the second law of motion. So this can also be further simplified by force equal to, force is directly proportional to, now what is momentum? Okay, wait, if you have a question, I'll teach me from the beginning. Okay, which part? Let me know. Which part of the lecture? From the second law. Okay, so Newton's second law of motion can be defined only by understanding momentum. Momentum is nothing but mass into velocity, right? So if I say that there is a change in momentum, then it is directly implied it is equal to change in velocity, because for a constant body, if I am not changing the body, if I am not changing the 5 kilogram ball, the mass will not change. Mass will always remain a constant. So if this momentum is changing, then only the velocity will change, not the mass. Mass will not change. So if momentum is changing, only the velocity will change and not the mass, right? So change in momentum is directly equal to change in velocity. So mass will not be affected by change in momentum. So if a body is remaining the same, if you have the same body, if you have the same material, then the mass will not change even if the momentum changes. So momentum change will only affect the change in velocity. Only if the velocity change, only if there is some velocity change, there will be a change in momentum, right? So according to Newton's second law of motion, force is directly proportional to rate of change of momentum. And rate of change banne बित्तिकै you should be aware about what is this. Rate of change of anything is change of that thing divided by change of time or total time, whatever it is, right? So if I say rate of change of momentum, then it is basically change of momentum by time. So now I know that force is directly proportional to change of momentum, rate of change of momentum or change of momentum. So change of momentum is denoted by delta p. So this sign is known as delta, and this represents change. So whenever you want to represent change of anything, just put a delta in front of that sign. So if I want to represent change of momentum, then I'll put just delta p divided by delta t. Or total time, I just put t. Forget about this delta t. I'll just put t here. Okay. Now what we do is, now we know that force is directly proportional to delta p. So what is p? We know p is equal to m into v divided by t. Now we know that mass cannot change, right? Delta m is not possible. So So mass is not changing for a single body. If I have a 5 kilogram ball, I will have a 5 kilogram ball. So I can't put delta m, so I just put m outside and I put delta v divided by total time. Or we can just put delta t as well, no problem. You can put delta t, right? Now we get a relation. F is directly proportional to m into delta v divided by delta t. Now this should ring a bell in your head. I think I've taught you in the previous classes. Change in velocity by time is nothing but the acceleration of a body. So whenever there is a change in velocity with respect to time, if velocity is changing with respect to time, that is acceleration. So force is directly proportional to m into a. So force is equal to, we put a constant of proportionality into m into a. So force is nothing but k into m into a. Force is a constant, proportionality constant, into m, mass of the body, into acceleration of the body. Okay. So in many cases we generalize k to be 1. So we put k equal to 1. So we just have F equal to m into a. So this is the Newton's second law of motion. So Newton's second law of motion statement is, Newton's second law of motion states that rate of change of momentum is directly proportional to force. Rate of change of momentum is directly proportional to force. So statement is, rate of change of momentum is directly proportional to force. Now after that we can derive. Rate of change is nothing but anything that is changing with respect to time. So rate of change of momentum is momentum changing with respect to time. So we have delta p, where delta represents the change of something. So delta p is change in momentum divided by total time, or change in time, delta t. So now we know that delta multiplied by momentum is nothing but m into v. So I had already written m into v divided by delta t. So now we know that delta is change, right? And we need to multiply delta m and delta v. But we know that delta m is not possible because mass is constant. So mass cannot change. So we don't put delta in front of m, we put the delta in front of v, delta v by delta t. So now this is a familiar concept. Change in velocity by change in time is nothing but acceleration. So we remove the proportionality sign in the next step, put a constant k, F equal to k into m into a. So we assume k to be 1 in most of the cases for our studies, right? So we put F equal to m into a. So force exerted by a body of mass m kilogram is F equal to m into a, where a is the acceleration of a body. So if I say I have a body of mass equal to 5 kilogram moving at a acceleration of who's accelerating at 2 meter per second square. So find the force. If you are told to find the force, so force will be nothing but m into a. So m is 5 kilogram into 2 meter per second square. This is equal to 10 Newton. So this is the way to do this. So force is nothing but product of mass and acceleration of a body. So this is Newton's second law of motion. So Newton's second law of motion, I'll repeat again. Newton's second law of motion states that the rate of change of momentum is directly proportional to force. So whenever there is a change in momentum with respect to time, that will directly imply force. That will directly be equal to or proportional to force. So we did all the derivation and found a relationship between mass and acceleration, and that is actually force. Mass into acceleration is force. So if you have any doubt, let me know.